So good morning, good afternoon, good evening for everybody. Welcome to this new general meeting of the Kilonova Catcher program. So today we are going to talk about where are we after the first 4 months of the O4 run. So I received a lot of emails asking me why there is no alert, there is something wrong in the system, or should I do something? So I will try to explain you what's happening and why it's normal that you got no GW alert so far, unfortunately. So, opala. So this is mainly the same outline than the previous meeting we did on June. So I will just give you the latest news about the GW detectors I got from my GW colleagues, I would say. And then we will go through the different events that have been detected so far by the LIGO Virgo detectors. And I will show you for the newcomers the how we selected the different alerts in Grandma to be broadcasted to the Kilonova Catcher astronomers. And as usual, we will finish with few feedbacks. I will try to answer to the feedbacks that you have written the last weeks. So we'll try to answer this at the end of this meeting. So I don't know how much time I will need to do this, but I'm sure it will be so long. I'm always saying that, and it's always 1 hour and a half meetings, so I will stop saying that. So let's start with the gravitational waves observatories. So I don't know how many newcomers are here, but for your information, on Earth we have four large-scale gravitational wave detectors. Two LIGOs in the US, one Virgo detector in Europe, in Italy, and one Japanese detector, Kagra, here. So unfortunately, so far the European and the European detector is not in a science operation right now. So the Japanese one is doesn't have the sensitivity required to detect extragalactic GW sources. So that's why I just put a cross here, and we don't expect any alerts from Kagra. So far, we still rely on the two LIGO detectors here, the Livingston and the Hanford detector. But the latest news I got from Virgo are that Virgo is going to resume its scientific operation, likely by, let's say, January 2024, beginning of 2024. So these are good news. So we finally see Virgo coming into the O4 run. So that's very good news, because so far we are only detecting gravitational wave sources with two detectors. And I remind you that we localized the sources on the sky by triangulation of the position of the timing and the position given by the two LIGO detectors. So the more detectors you have, the better will be the localization of the GW sources. There will be a break. I don't know how much time, but for the two LIGO detectors, they will stop working for few weeks. Likely just before the Virgo joins the O4 run, so that we will restart the O4 run with three detectors, so the two LIGOs and the Virgo. So this break should occur around December 2023 or January 2024. But note that this agenda, this scheduling is going to be updated every month. So this is the news. These are the news I have right now. But next month things could be shifted a little bit. But keep this in mind. This is the typical schedule we expect for the upcoming months of the offer run. So I hope that next time I will be able to remove this cross above the Virgo picture. I took this screenshot not yesterday, but on the 1st of October, so it was on Monday, or maybe Sunday, not remember exactly. This shows you the status of the different detectors, gravitational wave detectors. So I didn't mention GEO 600 detectors because it's a smaller scale GW detectors, and it's not really suited for our science detecting gravitational sources at extragalactic distance. So, but it's still some gravitational wave detectors that is on science operation. So when you have these large rectangles, this means that the detector is in scientific mode, so it's in under operation. And when you have this small rectangle here, this means that the detector is running, is alive, but it's not working on science operations. So what you can see here is that the LIGO, Hanford, and Livingston have long. So this is only for the 1st of October, this timeline. So you can see that the Hanford and Livingston are long periods of science mode. You can see also that during a given day, sometimes you have some breaks during minutes or hours, so it can happen. So it's not a 100% duty cycle on a given day. And you can see now, if you remember, when you will have time to look at the slides of the previous of the June presentation, there was just this line corresponding to Virgo. So now Virgo is alive, but it's not in science operation mode. It's in testing mode, I guess, or in calibration mode. So, which is good. Virgo is alive, and so we really hope that next year we could have 3 detectors, which will be helpful for having better localized GW sources, and which interests us for follow-up, optical follow-up of these sources. I'm showing you also this plot. So this is still for the 1st of October, which so this plot is showing you the typical average horizon distance for binary neutron star mergers for the 2 different detectors. So in red Hanford, LIGO Hanford, and in blue LIGO Livingston, as function of the time for the 1st of October. So you can see that the sensitivity of the detectors to binary neutron star mergers is stable as function of time, but you can see the different holes that are the same holes that you can see here, actually. So I will not well note that this number here right now for the 2 LIGOs it's around 160 megaparsec for binary neutron star. So this doesn't mean that we can't detect by BNS above this distance horizon, but this means that this is the typical distance horizon at which these 2 LIGOs detector can detect the BNS. And it's, as far as I understood from my GW colleagues, it's a bit below the expectation we had for 404. We were expecting the LIGOs to be more at around the 180 megaparsecs. So we are liking 20 megaparsecs in the horizon distance, and it has actually consequences on the rate of events we observe so far in terms of binary neutron star mergers. So I didn't recall the URL to check this, but these plots are completely public. If you want to have a look at the status of the detectors, GW detectors, here the BNS distance horizon, you can go onto this link and you will have access. It's publicly available. You can choose the date, and you can also look at the different dates for the two LIGOs. So hopefully, when Virgo will be alive, we will have also a purple curve here. So probably not at the level of LIGOs, of course. So that's for the status. Don't hesitate to interrupt me, ask questions if you have. I can't see the chat. I can't see if somebody is raising his hand. So don't hesitate if you have questions.
Yeah, I'll get the questions through if somebody writes in the chat. Someone said that Virgo will most probably in March.
Most probably in March. Okay. So maybe I got an optimistic colleague. I question an optimistic colleague. Okay. So actually, he told me beginning of 2024. So yes, I wanted to write January because maybe I'm too optimistic. But yes, let's say that it will be beginning of 2024. Okay, so we can move to the next section, which is the. I'll try to give you an overview of which kind of events have been detected so far during this run and what are the confirmed events. So far we got 49 detection candidates, significant detection candidates. So this means that they are above a certain threshold to be released publicly to the worldwide community. Actually, there were 58 candidates in total, but 9 were retracted afterwards. So we are still with these 49 pending candidates. Hopefully, they will not be retracted now. In terms of diversity of the different events that have been detected, so at the beginning of the run, there was NS, so neutron star, black hole merger events that was detected. So this is the event S230529AY. So I remind you that the letter at the end, so here is the date, it's the year, the month, the day, and the letters here are just the chronological order of detection of this event. So once you are C here, for example, this means that you are the third event of the 27th of June this year. And so this event was, well, let's say a known event between a neutron star black hole merger or a black hole merger. So as you can see, the probability of being one or other event are, well, pretty uncertain. And we got one also other events that is probably very likely a black hole merger, but there is a significant probability for this event for being a neutron star black hole merger event, but with a low probability. And the 46 remaining events are black hole mergers with a probability of being these kind of events greater than 95%. So as you can see here, we are mainly detecting BBH merger events during this O4 run. Unfortunately for us who are interested in electromagnetic counterparts, there is little chance for us to catch any EM light from black hole merger, especially because these BBH merger events are detected at very large distances, at cosmological distances. So the expected flux would be faint. And the other reason is that physically speaking, you don't expect any matter to be accelerated around black hole merger, let's say in normal conditions. So there is little chance for us to see some matter radiating electromagnetic counterpart after the merger of two black holes, except very special conditions, but still the distance of this BBH is large. It can be several gigaparsecs for the further events. I show you here some sky maps of those interesting events. So the two NSBH candidates, credible NSBH candidates. I think it's I wrote BBH, but I think it was a BNS. Okay, I will check later. So as you can see here, that this sky map on the right side is a sky map, a localization of the event, and it's likely provided by one detector. When you see this kind of sky map, this means that only one detector has detected the event. And of course, we are not going to send this to you because it's a waste of time. Even if it's probably a neutron star black hole merger, so where we could potentially observe electromagnetic counterpart, it's a complete waste of time to to try to scan this sky area for 4 hours. Of course, this kind of sky localization is much better. It's typically what we expect for us to perform follow-up observation, follow-up campaigns. I will show you why we didn't send this alert to you at the beginning of the offer run. So I already explained this in the June meeting, but maybe for the newcomer, I will explain again. Okay, so these are the, let's say, significant detection by LIGOs, by the two LIGO detector, but on top of this, you have plenty of subthreshold events, let's say. The number here is not correct. I forgot to update it, so I think we are close to 200 something. Actually, these subthreshold events are all types of events classified by the different pipelines running on the LIGO Virgo collaboration. It can be black hole merger, it can be binary BNS candidate, it can be NSBH candidate, it can be terrestrial, so typically noise that has triggered the detectors, can be unmodeled event, typically burst coming maybe from the collapse of massive stars that could produce gravitational waves, but not with the same model than for merger events. So you have the typical sky maps here related to some of those events. So you can see very artistic sky maps on the right side, for example. Some maybe more realistic sky maps on the left side, but still all those events have been well, not retracted. They are not retracted because there is no human in the loop in the LIGO Virgo collaboration side to check all those events. So they are just broadcasted, but most of the time, well, all the time, we do not take them into account because most of the time they are just noisy events. Just wanted to show you the last retracted event. So that was not a low significant detection event. It was a significant detection event, if I remember well. It was detected on the 18th of September. With a probability of being a BNS candidate 79%. So I was really happy when I saw the alert. I said, okay, yes, the offer run is starting, but unfortunately, this event has been quickly retracted afterwards. So as you can see, also the area was really large. So this is typically an event that we do not send to you because it's well, the probability that you find something in such a large area is very small. So we prefer to not send to you this large sky map to you, so that you don't waste your night on this kind of events. Okay. I'm moving forward the typical comparison table I present each meeting now. I show you on the left side here the expected annual rates here above for the different kind of events. So binary neutron star mergers, neutron star black hole merger, binary black hole merger. These numbers are annual rates prediction prior to the offer run. So they were made based on simulations and based on some hypotheses that the full LIGO Virgo Kagra network would have been operational for offer, and that the two LIGO BNS distance horizon would be at least 180 megaparsec, which was the level we had during the O3 run, according to my JW colleagues. So they confirmed me this. So we have actually none of this hypothesis is right now satisfied because we only have two LIGOs detector, and we are at 160 megaparsec right now for the two LIGOs detectors. So these numbers, 36 with the errors, 6 and 260, were based on this hypothesis. And also the localization, the size of the localization here were also based on this hypothesis. So as you can see, I showed you before that we have plenty of events, even for binary black hole merger, that are localized with several thousands of square degrees in the skies, and could be also much farther away than this distance amounts here. So when I compare those numbers, so I first try to compare those numbers with the observed monthly rate we have so far with these 4 months of run. And I ended with this comparison table. So you have the different event types here: neutron star black hole merger, binary black hole merger, binary neutron star merger. And I just converted those numbers with the error bars into monthly rates. Into monthly rates. So for neutron star black hole merger, you expect this. For BBH, you expect these numbers, and for BNS, you were expecting this prior to the offer run. Before the offer run was started, this was the number that we were expecting based on simulations. And these are the numbers we actually observe. So right now, based on 4 months of 04, so from the end of May to the end of September. So for neutron star black hole merger, we have 0.5 events per month. So this is in the right range of what was expecting prior to this run. And for binary black hole mergers, we are at almost 12. So we are close to the lower limits of what was expecting before the offer run, but we are still consistent with those numbers. The issue comes from here. Unfortunately for us, we have 0 BNS credible BNS candidates, so confirmed event, while we were expecting 4 per month, while we were expecting 1 to 7 for the most optimistic cases, events per month. So we have 0 so far. And this comes likely to the fact that actually the two LIGO detectors have a BNS distance range that is also lower than what was expecting. So we are, as I said before, more close to 160 megaparsec for the typical distance horizon of BNS merger detection. And if you take this number and you run the simulation again, actually 0, it's compatible with an expectation of when you have this distance horizon. So 1 to 7 is more when you are able to go further to detect even further away. So unfortunately, it's not in agreement with what what was announced by the LIGO Virgo collaboration, but it's unfortunately compatible with the current sensitivity of the available detectors. So this doesn't mean that we will stay at 0 for the whole for run, but it's a possibility that we have less actually events that we were expecting so far. This is actually what we observe. So I don't know if you have any questions about this, but as you can understand, this mainly explains why you didn't receive so far any alerts on the Kilonova Catcher website or by mail about gravitational wave detections. I will go through the different filters we use in Grandma to select the candidates that we then send to you. But if you have questions at this step, you can ask. Well, if there is no question, I will move to the next section about the Grandma alert. So actually, as you can read in the astronomer guide, we Grandma listen to the LiveGo Virgo alert stream, and then we broadcast to the Kilonova Catcher community the interesting events. Well, interesting that are supposed to be promising events for electromagnetic counterparts. And actually, those are the filters that are currently implemented to filter out the bad candidates and just keep the candidates that for which we expect the promising electromagnetic counterparts. So for BNS, we got this kind of filtering. We just kept the same filtering than before. We keep conservative filtering with respect to the distance, because usually when you have a large distance, this means that you have more chance to have only one or two detectors detecting the event. Right now, we are sure that we won't have more than two detectors, but in the future, when Virgo will be available, 200 megaparsecs probably means that you have only the two LIGOs detecting the events. So that's why we keep this threshold at 200 megaparsec for the distance, so that we can keep close events for which the electromagnetic counterpart would be bright enough also for our telescope settings. We'll still keep this localization accuracy threshold, so we should have only events that are localized better than 1,000 square degrees in the sky. We should have the probability of being a BNS event should be greater than 50%. The noise probability should be less than 10%, that this event is coming from a noisy event. And then we also put a standard threshold for the possibility of having matter ejected after the merger of the two neutron stars, and then also to have possible electromagnetic counterpart from this ejected matter. So it's 50%, 50%. For neutron star black hole mergers, so they can be detected further away than BNS. So we do not put any distance threshold on those kind of events. We just put a localization accuracy threshold. So still we want to keep events that are localized better than 1,000 square degrees, so that we think that we are able altogether to pave enough galaxies to identify the EM counterpart before it has faded away, and before the time, it's a race against time. So we need to keep the localization of the GW sources small enough so that we can save time for our telescope and for the follow-up campaign. And same probability for the event, and same for the terrestrial. So we do not put any threshold on the fact that potential matter can be ejected or radiated away. And we have added a new filter based on what I'm going to show you just after. It's a filter where you actually don't really know if the event is a neutron star black hole merger, or a binary neutron star merger, or if the classification between neutron star black hole or a binary black hole merger is not really secure. Typically, this event I showed you before, this one, as you can see here, we have 49% of chance of being a neutron star black hole, and we have 48% of chance of being a BBH. And if you apply this very conservative filter here, we have actually discarded this kind of event. So we try now to keep this kind of event when the probability is greater than 40%. Okay. So far, we got two interesting events, but unfortunately, each time they were not passing our criteria. So as I showed you in the beginning of this presentation, we got one NSBH event, but which was poorly localized, only with one gravitational wave detector. So we got 25,000 square degrees to cover over the sky. So impossible to perform follow-up observation with a significant chance of detecting something in this region. So that's why we didn't send this alert to you at the beginning of the run. Same thing for this event. So at the time where we implemented the filter, this event were not passing our selection criteria because it was just above this probability of event of being 50%. So now, thanks to the new filter, this kind of event would have been sent to you. And as you can see here, it would have been an interesting candidate to follow, actually. So hopefully we would have more of these candidates to provide to you for follow-up campaigns. Now, I got many mails asking me why I don't see any alerts on my dashboard. Is there something wrong in my settings, or should I do something? So I think I answered this question by presenting you the status of the different events that have been detected by the gravitational wave detectors and our grandma filtering system. But for those who wants to try tonight to be sure that they will see something once an alert will come, I will simulate a test alert with this ID. Actually, I was planning to do it right now, but I didn't check that. Well, normally the code should be okay, but there will be probably a demo effect. So I propose to all of you, if you have time, to connect very quickly on your Kilonova Catcher dashboard. So I took the sky map of this event, which was an O3 event, one of the binary neutron star merger that was detected during the O3 merger, and I ingested it into the Kilonova Catcher system to produce a test alert. So I will just here leave the presentation, try to connect hopefully again. No, I have to connect again. Up. So I will just launch an alert, and I will show you what you are supposed to see on your dashboard once the alert is coming. So let me just a few seconds to launch this alert. Should hopefully there will be no bug, but I can't guarantee this because I tried to make this just before the meeting, so I couldn't double check what I was doing. Okay, as you can see, there is a bug that is classical bug. I think it was okay. I see the point. Okay, demo effect. So what I'm going to do is to go here. I will go on my dashboard. Actually, I guess this is what I'm doing now is mainly useful for the newcomers. So I am super admin, so I have powers to revive some old alerts. So I don't know, maybe I will revive this one to up to tomorrow. So actually, not the right good example.
Okay, we can see it.
Yes, you can see it, but probably you have no observation plan. I'm not sure about this, so I will revive this old one also. Okay, so normally, here I am on my own dashboard. I have plenty of telescopes here. For this event, as you can see here, for this event here, I got an observation plan for this telescope, but not for the others. The reason why is that I think these telescopes were registered after this event was ingested in the system, so I did not update the observation plan for those telescopes. But typically for other events, you would have observation plan for several telescopes. So you can check your observation plan here, of course. It's going to download this CSV file. And in this CSV file, you can check the different coordinates you are supposed to observe with different right ascension and declination here. So there was a bug in the truncation here of the declination or the right ascension. I don't remember exactly. So it has been corrected but not pushed so far. So the bug is still here in the version of the software you will use when you will click on this button. But it has been corrected actually. So you can see that here for this event, I don't have any observation plan here. So this means that for these events, my telescope was not able to observe the localization of this gravitational wave alert. And we use as the threshold for all the telescope, we use an elevation above 30 degrees, at least, to provide an observation plan. So if I click on display alert, I will have all of the full information about some data about the gravitational wave events itself. Here you can choose the different telescope for which you are linked, your account is linked. So here I got my telescope. Okay. If I click on this telescope, for example, and I submit, you can see that here for this telescope, I have no observation plan for this telescope. If you believe that there is something wrong here, that you should have an observation plan, don't hesitate to contact us, and we could double check if there is an error on the code, because we can rerun the observation plan code as long as we want. So we go back to my telescope. You can change the time at which you want to see the visibility of the targets with respect to your local horizon here. So your local horizon here is the blue, the deep, well, not the deep, I don't know which blue it is, but this blue actually is your local horizon. So above which, so 30 degrees above the horizon, above which you can detect and observe the different pointings that are given here in red. The pointings corresponds to the position of the galaxies that we have selected for you, actually. And so you can see this sky map evolving as function of time. So you have to submit each time. And you can see when it is nighttime, the display is going to change into night. And you can see here that the position of the sky map has changed. So my telescope is on the northern hemisphere here. So if I can zoom in here, I think I have the Polaris star who is here. And so hopefully all the sky will rotate around this Polaris position. So you can check this at least if it's consistent with this physical behavior. You can download the sky map if you want to have it offline. And you can retrieve here all the pointings that have been scheduled for your telescope. So for this, my telescope, this is written here, my telescope. If I have selected another telescope, or if I wanted to push images coming from another telescope than my telescope, I should go here, select another one, submit. So here I have no observation plan, but then I would have here the tiles that have been scheduled for this telescope. So please, when you push images related to a given telescope, don't forget to select here the right telescope, and so the right tiles will appear here. So that when you will upload the FITS files, so here for each tile, so each pointing you have here, once you will upload the FITS file, it's going to link this image to this telescope ID. And then I will let you try this if you want. Later, I will have to produce observation plan for all of you for this test alert. So you can just drag and drop files here, or just click here and just check your FITS file here on the FITS file. And just click on your FITS file, and it's going to be uploaded on the image server and on our database. So this is I hope, pretty simple. There are still some bugs. I really apologize for this. We have a lack of manpower for developing the application, so I apologize for this. But everything is automatized. So once an alert is received from the LIGO Virgo, once it is filtered out by our selection criteria, it's going to be pop up in a first table here. Maybe I can show because actually. Tac. This one. Up. So you can see here I have two tables. There is one table for the follow-up campaigns I joined. I'm participating, or I just want to have a look. So to move a follow-up campaign that is here from the table of the follow-up campaigns that I'm not part of it, I just have to click on participate. And when I click on this, actually it's going to link my user ID to this event ID. And so that the system can know that you want to participate to this event. So I will click on participate. And here the event is now no longer in the previous table and now appear in the follow-up campaign I have joined right now table. So here I have no observation plan for this event because I deleted everything. There is a campaign deadline here. So as you know, this is we will keep this typical deadline for Kilonova search for about 5 days, if I remember well. But as you know, we can extend. I mean, I have the power to extend this campaign deadline. So if we think that we should have more chance, or we should keep longer observing these events, I can extend this. But the typical deadline would be 5 days for a given event. I think that's all for me for the demonstration and for what I wanted to present to you. So I will run a real alert, test alert. I will try to run it every day if I can, but actually I will run a real alert so that you are not lost and you see that the system is working all the time.
Damien, we have a few questions about your demonstration, I think.
Yes.
In the chat. So first one. Yeah, someone said that it could be good that when an alert is not observable from a given telescope site, that the web interface says not observable in the columns.
Okay.
So that it will avoid people asking themselves, well, I don't have observation plan.
Yes. I will add this here for now.
Also, apparently, when someone tried to click on observer plan, ops plans, but for this test alerts you just showed, but there was an error when doing this.
Yes. So when before in the previous table.
Maybe if you want to explain, Heinz.
When we click on the ops plan.
Yes, before when the table was here.
And right now.
Mm-hmm. For which event?
Actually, for any of them, for me.
Yes.
So like the last one.
Okay.
I can see only 2 events.
You can see only 2 events.
Yes, as
Interesting.
as an LVC.
Okay.
S2002113T and LVC-MS and so on.
Okay, and you don't see this one. Okay.
Yeah, I think for me the server error happens when I join the campaign. So I haven't joined the campaign, but when I click on the join the following campaigns thing on any of the telescopes, it gives me a internal server error.
When you click on this button, I'm showing right now.
No, I don't have that exact button because I haven't joined the campaign yet. So.
Yes, okay. So I see. Yes, it's a recurrent bug that actually we shouldn't display this button because they are not active when you didn't join the campaign. So we should not display them actually. So we should only display this button once you have joined the campaign.
Yeah, but for me now, there's no way to join the campaign. Wherever I click, it gives me an internal server error.
Okay, even when you click on participate.
Yes.
Okay, interesting. Okay, I see. Well, that's an interesting bug. Maybe because these are all events. I will try. Can you try? Well, we are debugging live. I will revive this event. Can we try to see if you have access to this event?
Okay, so I guess I have to refresh.
This GRB event.
GRB 230812B. Let's see. I also get a 500 internal server error. Something is broken, it tells me.
Okay.
For the GRB, it works.
Oh, that's weird. Not for me.
Get
Yes.
the tiles.
Okay, well, we can
Only
solve
one.
this probably. Yes, you have only one because it's a GRB, so we just have one pointing. It's a very well localized source, so that's normal. Okay, can you, Bert, can you send me a screenshot of where you are clicking and the error message? I will try to have a look.
Sure.
And
Okay.
another question from Arno was that is not clear to him that in case of an alert, do we get a mail or a SMS?
There will be no SMS, unfortunately. It should have. You should receive a mail if you have clicked on this when you register to here. When you click on this button and you validate, receive email for alerts. You should receive an email, but so far it's not implemented yet. I apologize for this. Once we will have an interesting event, probably this function will not work at that time. So we will send an email via the mailing list. So you will still receive an email, but it's not the automatic email we wanted to create at that time. It's still a to-do list action, but not yet implemented, unfortunately. But the thing is that you will receive also a Slack message. Slack. So if you go on Slack, this is Grandma GW alert. You will receive the alert message here. So the format of the alert, the Slack alert here is not very user-friendly. I will update it, but this is where also you will get the alert message. So you will get the alert message automatically from Slack, from the website, and manually we will send the mail through the mailing list. So you should have the information at some point, hopefully. So if there is no other question, we can go through the different feedbacks. So some of you have, well, I think these are the feedbacks I already answered, actually.
Yeah, I think so, yeah.
Okay. So the methodology is not that easy to understand at first, but with some more explanation in practice, I can get there. So I agree that it may be not straightforward, and we have a lack of practice because we have no alerts so far to observe. I really have to automatize the test alert so that you can try to see how it works. I will try to do this by November, I will try to implement this automatic test alert. So don't forget that if you are lost, you have still this when you go into the FAQ. So maybe I will come back to dashboard FAQ here. If you go to the last one, what is the typical follow-up strategy to implement a GWBNS alert comes in? You have these documents that give you the typical guidelines to go through the different steps from the reception of the alert to the transfer of your images. So if once you read this, you have still things unclear in your head, don't hesitate to send me a mail. I will try to help you to better understand the process. And we just want to get more alerts. I agree. I agree. Actually, we have sent an alert while still manually because this is not automatically taken into account. But this August, on August, we have sent an alert for a gamma burst because we want you to keep practicing, and it was a very, very interesting gamma burst. I have prepared 4 slides if you want to have a look of what has been done by you and the Grandma team. But we are fully aware that there is no much alert to look at so far, and you can believe us that in Grandma we are also a bit disappointed of this. That's why we try some to get some follow-up campaigns for very interesting events that are not part of the GW science, but that's something we try to do. But if you want us to send you more different kind of alerts, we can think about it, but we would like to keep focusing on GW still for at least the rest of the offer run. We could think about sending alerts for very special events, but it would be manually made.